G concave down? Well, G prime of x is the same thing as F prime of x. And we need to know when it's concave down, so I need to know when is this, again, negative. Now, here's a tricky one. F prime is a direction. It's a slope. So where is F heading downward? That is from 6 to 15. Both of those are exclusive. Okay, 6 to 15, because G double prime of x, which is F prime of x, is negative. You could have also said F is decreasing there. Okay? Some of y'all like to use the words decreasing and negative interchangeably, and they are not. Okay? They are not. Part D, find the trapezoid approximation. Without going into a lot of detail, just do left, what was it, 6 subintervals? Left 6, right 6, and average them, and I think you get 12 for that. Yep. This one ends up being 12, this one ends up being 12, so when you average them together, you get 12. I'll leave that to you. All right, I'm not going to do the next one because I've already done the next one. That was your question on your test. How are we doing on time here? Okay, now we get into the non-calculator stuff, which is where some of y'all just kind of bombed it. Alrighty, we are doing 2003 number 6. Okay, this is the one that is defined like so. You have f of x, this one I like, I love this question by the way. F of x is equal to square root of x plus 1 when we are going from 0 to 3, and 5 minus x when we are going from 3 to 5. Okay, part A. Is f continuous at x equals 3, why or why not? For those of you that use the word limit somewhere in your answer, you got more credit than those that did not. That is how you tell continuity. By definition, if the limit, as you approach some number from the left, is the same as the limit as you approach that same number from the right, and the third condition, that is the actual answer you get when you plug in the function value, then you're good to go. Think about this. Here, the limit from the left and the limit from the right are the same. So limits exist, but if the actual point doesn't fit there, then you're kind of, I have too many less than and greater than. This one's not equal to. Okay, so what I really needed to do was to check out the limit. All right, limit as x approaches 3 from the left of f of x. All right, so that's this side. If we plug in 3, we get 3 plus 1 is 4, root of that is 2. Limit as x approaches 3 from the right. All right, that's this one. Stick in 3, 5 minus 3 is 2. And f of 3, which is from this guy, is still 2, therefore we are continuous. Because, and then I would write that, the limit from, and you could say the limits match. At this point, once you've stated it, the limits match, or are heading to the same place, the limits equal each other, whatever you want to write. Let's see. Find the average value. Okay, the thing about the average value on this one, our formula for average value says find the total area and then divide it. This area is broken into 2 pieces, so you would need to do this. You would need to find from 0 to 3 of this guy, which is a tiny u sub, okay, tiny. And then add it to the 3 to 5 of this guy. right? And then once you got that answer, then you would take the distance, which is 1/5. Some people on this one found the total. This, by the way, I'm not gonna go through it because you can do the antiderivatives. A lot of y'all did a good job of getting this, that the area is gonna be 20/3 if you put that together. A couple of y'all forgot to bring down the 1/5 there and get 4/3 for your final answer. I know I haven't written the antiderivatives, but I figure y'all can, it's written on the paper, the answer key, and y'all can figure it out. C, now this is one of my favorites. I absolutely love C. Suppose that function g is defined like this. So again, we have a piecewise function. We have k times the root of x plus 1 for 0 to 3. And you have mx plus 2 for 3 to 5. So kind of the same feel, kind of. Line on the bottom, root on the top. Where k and m are constants. If g is differentiable at 3, then what are the values of k and m? All right, here's something you need to understand. Differentiable means that you were continuous, which means you had limits. We're only going to need these two, okay? If I am differentiable, two things have to happen. Number one, those two graphs have to meet at the same spot, and number two, their slopes have to be the same. If they're not, if the slopes don't match up, then it's not differentiable. If they don't sync up like little Lego pieces, then they're not continuous. So I need to show, in theory, that the two pieces are equal and that their slopes are equal. I'll go ahead and take a derivative. All right, g prime of x. Irritating derivative, let's see. That's going to be 1/2. Okay, so k over 2, well, okay. K 1/2, that to the negative 1/2. K over 2 root of x plus 1, and y'all can do a derivative and figure that out. And then this one is just going to be m. So I need to show these two are equal, and I need to show these two are equal. So let's start with these two. K root of x plus 1 is equal to mx plus 2. And the only place that is bad, that's a beautiful graph, that's a beautiful graph. The only place that it could go wrong is at 3 where they meet. So I'm going to plug in 3. And I'm going to, that's 4, 2. So I get 2k is equal to 3m plus 2. And I'm going to put that on ice. Okay? Then I'm going to do the same thing with this guy. K over 2 root of x plus 1 is equal to m. We'll plug in 3, because that's where I need them to meet. K over 2 times 3 plus 1 is equal to m. Root of that is 2. All right, so we get k over 4 is equal to m. And there it is, ladies and gentlemen. I'm going to take, it honestly doesn't matter, or you could say that k is equal to 4m. I'm going to take one of these and plug them in, so I'll do it right here. I'll take this k, stick it in right there. So I get 2 times 4m is equal to 3m plus 2. That gives me 8m equals 3m plus 2. 5m equals 2, so m equals 2/5. That's 1 down. Then take that one, plug it back in. I would get k is equal to 4 times 2/5, so k equals 8/5. Nobody tried, well, I think one person, maybe Michael, tried C. Everybody else did a fantastic job on A's and B's. A lot of people mentioned limits in the first one, but didn't actually go into enough detail. If you have something like a +1 or close or something like that, you at least use the word limits in your problem. They needed to see exactly what the limits were though. All right, last one on the back. We will make this super fast because I know Amber needs to go. You can go ahead and go if you want to. You got the answer. You don't have the answers?
Yeah.
Okay. Okay, super duper quick. All right, so we are given that the velocity of some particle is -1 plus e to the 1 minus t for t greater or equal to 0. Got it. All right, part A. Find the acceleration of the particle at 3. So I need acceleration, which is going to be the derivative, so that's 0. This is going to be a chain rule. We get e to the 1 minus t, but then you chain it and you get a -1 there. So a of 3 is going to be -e. Stick in 3, you get -2. You could also write that as -1 over e squared. Either one of those would work. So you need to find the velocity and plug in that. Okay, B. Is the speed of the particle increasing at time 3? Y'all didn't do a great job on this one. Speed. Speed, you need to look at both velocity and acceleration. If they're both positive or both negative, then you're speeding up. If one is positive and one is negative, then you're slowing down. So I already found out from here that a of 3 was negative. Okay, so all I need to know now is what is v of 3. Well, if I stick in v of 3 here, I'm going to get e to the -2, which is that. Okay, -1 plus that, that's not big enough to go over -1, so that's also going to be negative, which means we are speeding up. Because they were both negative. If one had been positive and one had been negative, this technically means I'm speeding up in a backwards direction. I'm in reverse with my foot on the gas. C. Find all values of t for which the particle changes direction. All right, I need to set my velocity equal to 0. I'm going to do e to the 1 minus t equals 0. Might actually get you a point. I don't think it did on this one. First thing I'm going to do is add 1, so e to the 1 minus t is equal to 1. Take the natural log, you get 1 minus t, natural log of 1 is 0, and then solve and get t equals 1. We haven't actually shown that it changed direction, so I need to do my little number line. Here's 1. Stick in something like 0, you're going to get -1 plus e, which is positive. Stick in something like 10, you get negative, or actually 3, we've already used that one, we got a negative. V of t. That's not enough, you need to give the sentence, changes direction because v of t changes sign there. Blah, 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 here, I'll fill it out, you know that. Part D, find the total distance traveled. Okay. It'd be great with the calculator, I can just slap an absolute value on it and be done. This isn't a calculator. The Green Sea kids all gave me a decimal answer, which was correct because they used the calculators, but couldn't use calculators on this one. So you basically need to do two separate antiderivatives. You need to go from 0 to 1, and then from 1 to 3. V of t. I don't feel like recopying, but there's that. This one is going to be the positive one, and this one's going to be the negative one, so I need to flip-flop that around. Do the math, Bob's your uncle. Okay. Let me hold, I need to put an actual grade on the free responses, so let me hang on to that till tomorrow. I'll go ahead and turn that off. Great lesson. Okay. Probably way more time than they've got to. Go back to the beginning, and I should have told you to fast forward through all the slow stuff, so I hope you made it this far. Thank you, love.